Welcome to Lesson 13 at the Institute. This is optimization in League of Legends. We need to figure out, using Lagrange multipliers, which items are best in a given situation in a game of League. We'll start out by finding the objective function, then we'll apply Lagrange multipliers, then we'll solve the system that results, and then we'll interpret the answers at the end. Yeah, let's do it. So, number one, we need to find the objective function. So, if you are trying to optimize something, basically you first have to narrow down exactly what it is that you're trying to optimize. What we will do is use the base items up here in the upper right corner to put a price on health, magic resistance, and armor. Then we will calculate what is the survivability function based on health, magic resistance, and armor. That survivability function will be our objective function. So first, prices. Got in the upper right corner there that cloth armor costs 300 gold and gives you 15 armor. 300 gold for 15 armor means that you get what? It costs 20 gold for each armor. I've got a null magic mantle, that's 450 gold for 25 magic resistance. If you divide that, what is that, 18? That's awkward. 18 gold per magic resistance. And then a ruby crystal is the base way to get health. That costs 400 gold. Gives you 150 HP. Oh no. What is this, 8/3 or something? No. Yes, 8/3. 8/3 gold for each health. So we'll have to keep track of that. These are our prices for each item. It's not, this means that this plan of writing the objective function is going to leave out the fact that some items are more efficient than others. I will just assume that every point of armor costs 20 gold, just so that it's possible to do this calculation. Then you can think of a thornmail as having a heavy discount, instead of thinking of the price of armor as actually being lower than it is. It's tricky, but this is what we're doing to get an objective function. Okay. To actually turn this into something to optimize, I want to make the function be how many hits it takes to kill you. So this is hits. It is a function of your armor, your magic resistance, and your health. It somehow depends on your armor, your magic resistance, and your health. What we'll do is we'll just say, okay, let's suppose that a hit is one. The problem is there might be some physical damage and some magical damage. So let's assume that a hit is 1 magic damage and R physical damage. This R, this parameter R, it will depend on the game that you're in. If your opponents, it's not just your opponents, if the people hitting you are doing 3 times as much physical damage as magic damage, then R is 3. If the people hitting you are doing about this equal amounts, then R is 1. If the people hitting you are doing way more magic damage, then you might just say, whatever, R is 0. Yeah. Once we've decided that each hit is 1 magic damage and R physical damage, then the number of hits you can take is, well, you take your health and you divide it by, yeah, I'm sick of writing HP, so we'll just call it H. You divide it by, how does it work? It's like 100 over 100 plus your armor for each physical hit. So I guess it's like this. And 100 over 100 plus your magic resistance for taking 1 magic damage. If you take 1 magic damage and R physical damage, the 1 magic damage gets mitigated by your magic resistance. The R physical damage gets mitigated by your armor using this formula. This is just how armor and magic resistance happen to work in League. This is already pretty obnoxious that I will have to write 100 plus armor and 100 plus magic resistance repeatedly. So let's get that out of here. We're going to let X be 100 plus your armor, and we'll let Y be 100 plus your magic resistance. We will still buy X and Y at the same prices that we were buying armor and magic resistance, because to make X go up, you just buy 1 more armor, and to make Y go up, you buy 1 more armor. But it means that our objective function will be easier to understand. It's the hits given your X your y, and your h. This is your 100 plus armor, 100 plus magic resistance, and your health is just this function, h over 100r over x plus 100 over y. So this is the function that we're trying to optimize. I want the number of hits it takes to kill you to be as high as possible. We want to maximize hits. Hits starts with H, which is the same thing as health, so I'm off hits, we'll call it F. F is the number of hits of 1 magic damage and R physical damage that you take. We'll maximize F. Okay, once you've got the objective function, this is still kind of ugly. Can I like clear the fractions somehow? Is that even a good idea? I think it is. Yeah, let's multiply the numerator and denominator by xy. And let's multiply it by 100 actually too. So I'll have a new function capital F. Just to make our life a little easier, it'll be 100f. So the 100 will cancel these hundreds. And then capital H, I'll multiply the numerator and denominator by xy. So I'll have, oops, no, 100. I'll have ry plus x. To maximize lowercase f, I can also maximize capital F. So that will be my plan now, is that I've kind of like massaged the problem to the point where I have a pretty simple equation, a pretty simple function to maximize. I'm thinking of lowercase r as a fixed constant that you will know at the beginning of the game when you look at the enemy team comp. And then h, x, and y are the things that we're trying to purchase to maximize capital F. Capital F is actually how many times you can take 100 magic damage and 100 R physical damage. But our survivability, capital F, is a function that gives us our survivability. So we're maximizing capital F. That's number one. This is the objective function we'll actually use. F of x, y, h. Let's put the inputs in alphabetical order. H, x, y is hxy over ry plus x. So that's step one of the plan. Find the objective function. This is what we're trying to optimize. Step two is we want to actually use Lagrange multipliers. Now, to actually use Lagrange multipliers, I need a constraint function. So what is that constraint? The constraint is that you have finite money. Let's say that you have K gold. I don't really care how much it is. What we're hoping to get out of the final answer is like, what are the right ratios of health to magic resistance or health to armor or armor to magic resistance? If R is 2, if you're taking twice as much physical as magic damage, do you want twice as much armor as magic resistance? I don't think so. So we're just going to let K be the amount of gold. This is the amount of gold you have to spend on X, Y, and H. So how do you buy it? Well, you buy it using these prices that we found at the beginning. X is 100 plus armor, so it costs 20 gold each. Y is 100 plus magic resistance, and magic resistance costs 18 each. Health costs 8/3 each, and this all adds up to K. This K gold is not it's not just your literal gold that you're spending in the shop. It's also the gold that's represented by your initial stats that might come from runes or just your base stats of your character. Champion, whatever. So this is our constraint. This means that I can write my constraint function, g of h, x, y, as this thing that what object is supposed to equal 0. So it'll be 8/3 h, 20x, and 18y minus k. This is what equals 0. So we've got our objective function and our constraint function. That's enough to set up Lagrange multipliers. If I can spell. Lagrange multipliers say Lagrange multipliers have two specific formulas that you use. You've got that the gradient of f is a multiple of the gradient of g, and you've got please actually satisfy your constraint. So let's get these. The gradient of f, f is kind of a mess. F was hxy over ry plus x. Gross. So the gradient of f, and I'm putting h first, then x, then y. The gradient of f is kind of a mess because it has a bunch of quotient rule in it, but that's okay. So I need the denominator times the, I'll do h first. So the h partial derivative of the numerator. Wait, what? The denominator is a constant. So for h, I don't have to do this. The h partial derivative of f is just xy over ry plus x. The h partial derivative of g is 8/3. So I just have 8/3 lambda. For the x partial derivatives, I do the quotient rule. So denominator times x partial derivative of the numerator minus numerator times x partial derivative of the denominator all over denominator squared. In the numerator, I've got rhy squared and then hxy minus hxy. Those cancel. So that's all we get in the numerator. This is supposed to equal lambda times the x partial derivative of g. So I get 20 lambda. Okay, we're going to need some more space. Do the y partial derivative. The y partial derivative of our objective function. Remember, this function is how many 100 magic damage and 100 R physical damage hits I can take. Bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. hxry minus hxry, those cancel. So the numerator just has hx squared over this weird denominator. This is supposed to equal lambda times the y partial derivative of g, which is 18. So 18 lambda. So these are the gradients are equal part of the system. Then I also have g equals 0. G equals 0 is just the cost constraint. It says that 8/3 h, 20x, and 18y is a constant. Okay, so this was Lagrange multipliers. This was step 2. Now we can move on to step 3. Step 3 is I actually need to solve this system. I've got 4 equations in 4 unknowns. Let's clean this up just a little bit, even though this is awkward to do, just so that you can see exactly what the 4 equations are in 4 unknowns. The unknowns are h, x, y, and lambda. As always with Lagrange multipliers, we don't actually care what lambda is, but we could solve for it if we wanted to. Sometimes that's helpful. Probably not this time. So we're looking for some way to solve for h, x, and y here. I think the easiest thing to do is to probably notice that these second 2 equations off on the side are pretty similar to each other. So I'll name the second equation equation 2 and the third equation equation 3. 20 and 18 are in a 10:9 ratio. So I'll do 9 times equation 2 minus 10 times equation 3. If I do 9 of these minus 10 of these, then the right sides will cancel. So I'll just get that 9 rhy squared over my weird denominator is the same thing as 10 hx squared over weird denominator. Weird denominator here is never 0. 100 plus my armor plus 100 plus my magic resistance is not 0, so I can multiply both sides by this denominator, and we are in business here. My health is never 0, that cancels. I now have a relation between x and y. This answers the question already of when you are getting hit by a certain ratio of physical to magic damage, what should your ratio of armor to magic resistance be? Let's just solve for x. I'll have 9r over 10 y squared, all square rooted. Let's get this written a little bit better. It's going to be 3 square root r over square root 10 y. Yeah, okay. So this is already like a usable fact. Remember, x is 100 plus your armor. R is the ratio of physical damage to magic damage that you're taking. And Y is 100 plus your magic resistance. So even though we haven't solved for the exact values of X and Y, this tells us the ratios that you're supposed to have. So for example, let's say that R is 2. Is there like a nice number? No. Let's say R is 2, and you've got 30 magic resistance. Then you can plug all this in here. X is 3 square root of 2 over square root of 10 times 130. Three square root of 2 over square root of 10 times 130. Because R is 2, we expect to need more armor than magic resistance. Yeah, X is 174.4. So with MR 30, if you're taking twice as much physical as magic damage, your armor should be 74.4. Notice that you need more than twice as much armor to deal with twice as much physical damage. Okay, let's name this equation because this is the first like usable equation that you can just use this in games. You would probably need to make a little JavaScript calculator or something. You could make like a table maybe, but this is the optimal way to survive hits of R physical damage for each 1 magic damage. Okay, we need to keep solving because I want to know how much health I should have. So let's get a new page here. My equation star is that X is, what was it? 3 root R over root 10 Y. Okay, we've got our equation star. So we know the ratio of armor to magic resistance. To get health into the picture, we need to include another equation somehow. So let's include the first equation in that list from Lagrange multipliers. It was just that xy over weird denominator is 8/3 lambda. We know this, and then let's get a different equation that has h in it, because I now want to know how h actually relates to x and y. Let's get the one with fewer r's. Hx squared over ry plus x squared is, it's not 15. What is it? 18 lambda. If I combine these together and then use star, I should be able to eliminate lambdas the same way I did last time. And then I'll eliminate x probably. So I'll just have h's and y's. So how do I make these be common? This has like a lot of 2's. And this only has 1 2. So I'll need to multiply equation 3 by 4. This I need to clear a 3, and then I need 2 more 3's. Oh my gosh, so I need 27 1's. 27 copies of equation 1 looks like 27xy over ry plus x equals 872 lambda. 4 times equation 3 is 4hx squared over weird denominator is 72 lambda. These are equal to each other. So combining these two together, I get that 27xy over ry plus x equals this other one, 4hx squared over ry plus x squared. Let's clear the denominators. I'll have 1 extra ry plus x on the left. Okay, I now have h in terms of x and y. I want h in terms of just like one thing. So let's solve for h. It's going to be 27xy over ry plus x all divided by 4x squared. Cancel an x. X isn't going to be 0. That would be negative 100 armor. And then I know x in terms of y, this equation star. (27y). I need ry plus, what was this? 3 root r over root 10. Let's write it as 1 square root. Square root of 9r over 10 y. And x here is also square root of 9r over 10 y. Okay, let's cancel as much as we can. Here's a y, and I can factor out a y, and I end up with another usable fact. H is 27/4 times r plus root 9r over 10 all over root 9r over 10. Okay, it's not usable yet, and there's one y left over. Any good way to write this? I guess r divided by this is root 10r over 9, and this divided by itself is 1. Yeah, this works. Okay, so now you're in Excel spreadsheet territory, but if you know your magic resistance and you know the ratio of armor or of physical to magic damage, you can find your health also. So let's combine these together. We basically solved the system. You never actually know like your total value of all your stats, k. So there's not much point of actually solving for h, x, and y exactly. The ratios are the usable facts that you'll actually be able to use. So let's apply them and interpret them. So I've got, these are the two usable facts. Well, let's summarize. X is 100 plus your armor. Y is 100 plus your magic resistance. And you take R physical damage for every 1 magic damage taken. In this situation, and when we've assumed that all health, armor, and magic resistance cost a flat amount of money, so you're like thinking of upgraded items as having a discount instead of lowering the average value of armor, the optimum way to do this is equation star and equation star star. Equation star tells us that your armor is this multiple, well, your 100 plus armor is a multiple of your 100 plus magic resistance. That multiple is 3 root r over root 10. I'm actually coming around to writing the whole thing as 1 square root 9r over 10, since this number is going to show up again. Okay, and then equation star star, which we just found, where was it? It's 27/4 weird number plus 1. Where is it? 27/4 weird number plus 1 y. So let's just do some examples. If, let's say that you have r is 1, taking equal physical and magic damage, and you have 40 magic resist. That means y is 140. The optimal armor and health in this situation is given by the two formulas, star and star star. Star tells you that x is this ratio times y, so it's root 9/10 times 140. You would have if you cared about this a lot, you would have a spreadsheet that would just do this for you. So this is 132.8, and so your armor is like 33. MR is 40. If you have 40 MR, the optimal amount of health is given by the star star formula. And it's just some big mess. It's 27/4 times square root of 10/9. R is 1 in our situation, and I multiply the whole thing by 140. My optimal amount of health is 1941. This is crazy high. If R is a different number, for example, if you take 4 times as much physical as magic damage, then you let R equal 4, and you get different answers. But the overall deal here is that people way overbuy armor and magic resistance. The optimal number of hits you can take is improved significantly by buying health early. This is part of why Frozen Mallet was amazing, because it tricked people into buying health. So buy more health,